Picture this. It's a bone-chilling winter morning in Minnesota, temperature sitting at -20 degrees Fahrenheit. Most people wouldn't dare step outside without layers of clothing, yet there's a man jogging through the snow in nothing but shorts and sneakers, steam rising from his skin as if he's generating his own personal heating system. Is this person superhuman, or are they tapping into something that all of us potentially possess? On May 20th, 1999, a 29-year-old Swedish radiologist named Anna Bagenholm made medical history in the most terrifying way possible. While skiing, she fell through ice into a stream, becoming trapped under a layer of ice for 80 minutes. When rescue teams finally pulled her out, her body temperature had plummeted to 13.7 degrees Celsius, the lowest recorded body temperature for anyone who survived. By all medical understanding, Anna should have died. Her heart had stopped, her blood had essentially frozen, and yet she not only survived but made a complete recovery. Her case forced scientists to reconsider what they thought they knew about human survival limits. But Anna's case isn't isolated. In the remote monasteries of Tibet, monks practicing an ancient technique called tummo have been documented sitting in meditation while wearing nothing but thin robes in sub-zero temperatures, their bodies generating enough heat to dry wet sheets placed on their shoulders. Western scientists initially dismissed these accounts as folklore, until they began measuring the monks' skin temperatures during practice, and found increases of up to 17 degrees Fahrenheit in their extremities. These extraordinary cases sparked a revolution in our understanding of human thermogenesis. Dr. Maria Hoppmann, a physiologist at Radboud University, began investigating these phenomena and discovered that some individuals possess what she calls metabolic superpowers. Through controlled laboratory experiments, she found that certain people can consciously influence their autonomic nervous system, something previously thought impossible. The key lies in brown adipose tissue, or BAT. Unlike regular fat, brown fat is packed with mitochondria, the powerhouses of cells that burn calories specifically to generate heat. Most adults have very little brown fat, but some individuals have significantly more, and even more remarkably, some can activate it on command. When exposed to cold, these people's brown fat begins working like a biological furnace, burning through calories at an astounding rate to maintain body temperature. Enter Wim Hof, known as the Iceman, a Dutch extreme athlete who has shattered every record for cold exposure. Hof can sit in ice baths for nearly 2 hours, climb mountains in shorts, and run marathons in the Arctic barefoot. Scientists studying Hof discovered something unprecedented. He can consciously control his immune response and body temperature through breathing techniques and mental focus. Blood tests showed that during cold exposure, Hof's body produces stress hormones and anti-inflammatory proteins in ways that shouldn't be possible through conscious control. But here's where the science gets truly fascinating. Researchers found that Hof's abilities aren't unique to him. When they trained volunteers in his breathing and concentration methods, these ordinary people began exhibiting similar physiological responses. Their brown fat activated, their inflammatory responses changed, and their tolerance to cold dramatically increased. This suggests that the potential for cold resistance might be dormant in all of us. The genetic component adds another layer of mystery. Studies of the Inuit people of the Arctic have revealed genetic adaptations developed over thousands of years. They possess variants of genes that regulate fat metabolism and heat production, allowing them to maintain body temperature in conditions that would be deadly for most humans. Similarly, the Sherpa people of the Himalayas have evolved enhanced oxygen processing and cold tolerance that enables them to thrive at altitudes where others struggle to survive. Recent research has uncovered even more intriguing possibilities. Scientists have identified specific genetic mutations that affect the UCP1 gene, responsible for heat production in brown fat. People with certain variants of this gene can produce heat more efficiently and feel comfortable in temperatures that leave others shivering. But perhaps most remarkably, epigenetic studies suggest that cold exposure itself can actually turn on genes related to thermogenesis, meaning that regular cold exposure might literally reprogram our DNA. Dr. Susanna Soberg's research at the University of Copenhagen revealed that people who regularly engage in cold water swimming develop what she calls cold adaptation syndrome. Their bodies begin producing more brown fat, their blood vessels become more responsive to temperature changes, and their overall metabolic health improves dramatically. Some participants reported that after months of cold exposure training, They genuinely stopped feeling cold in situations that previously would have been unbearable. The implications extend far beyond personal comfort. NASA has begun studying cold adaptation for space exploration, where temperature regulation could mean the difference between life and death. Military researchers are investigating whether soldiers could be trained to operate effectively in extreme cold without bulky protective gear. Medical researchers are exploring whether controlled cold exposure could treat metabolic disorders, depression, and inflammatory diseases. Some of the most compelling cases involve people who developed extraordinary cold tolerance after traumatic experiences. There are documented instances of individuals who, after surviving hypothermic incidents, seem to permanently alter their relationship with cold temperatures. Their bodies appeared to have learned from the trauma, developing enhanced mechanisms for dealing with cold stress. But the phenomenon raises profound questions about the nature of human potential itself. If some people can consciously control their body temperature, what other supposedly automatic bodily functions might be brought under voluntary control? Heart rate, immune response, pain perception. The boundaries between conscious and unconscious bodily control are beginning to blur. The therapeutic applications are already being explored. Cryotherapy, once considered alternative medicine, is now being prescribed by mainstream physicians for everything from arthritis to anxiety. Controlled cold exposure is being used to treat autoimmune disorders, with some patients reporting dramatic improvements in conditions that had been resistant to conventional treatments. Yet this power comes with risks. Extreme cold exposure without proper training can be deadly, and there's growing concern about people attempting dangerous cold challenges they see on social media. The difference between therapeutic cold exposure and potentially fatal hypothermia is a narrow margin that requires scientific understanding and careful progression. As we stand on the brink of potentially unlocking these abilities in the general population, we face ethical questions that seem straight out of science fiction. If we can enhance human cold tolerance through training, genetic therapy, or pharmaceutical intervention, should we? What are the long-term consequences of deliberately altering human physiology? And if some people naturally possess these abilities while others don't, what does that mean for human equality and opportunity? The most extraordinary aspect of this research is what it reveals about human adaptability itself. Our species has survived ice ages, migrated to every continent, and thrived in environments from scorching deserts to Arctic tundra. The capacity to resist extreme cold might not be a superpower at all. It might simply be part of our birthright as humans, waiting to be rediscovered. The next time you see someone walking comfortably through a blizzard while you're bundled in layers, consider this. They might not be tougher than you. They might simply have awakened something that lies dormant within all of us. The question isn't whether humans can develop resistance to cold. The evidence is overwhelming that we can. The question is whether we're ready to unlock the full potential of what it means to be human. In laboratories around the world, scientists continue pushing the boundaries of what we thought possible. They're discovering that the line between superhuman and human might be far thinner than we ever imagined. And perhaps that's the most chilling revelation of all. Not that some people possess extraordinary abilities, but that those abilities might be extraordinary only because we've forgotten they exist within us all.